Okay, I want to welcome you to this lesson. As we discussed last time, we would like to look at how you can query data from databases. Last time we did look at an overview of SQL Server. We said that SQL Server is a database management software. That is the software that you use to manage databases. And we did say that for SQL Server, you normally interact with the SQL Server Management Studio to work with databases. And I did briefly look at what the parts of the SQL Server management window. As you can see from here, mainly we'll be using the Object Explorer, the Query Editor, and the menus and toolbars on top. Now, in databases, we are talking about relational databases, and we say that relational databases, information is stored in tables. Just a moment. Okay, so I was saying that in a relational database, information is stored in tables, and then you define how those tables are supposed to relate to each other. In other words, you establish relationships. So for example, in a library, you might have a table for members where you have member ID, first name, last name, date of birth, address, and so on. And then you can also have another table for books in the library where you might have a catalog, maybe ISBN number, title, author, publisher, and you might also have another table which will be loans, where you have maybe loan ID, maybe debt, book bond, book catalog number, member ID, and so on. Okay, so information is going to be stored in each of these tables. So once you have defined the structure of the database, you need to be able to retrieve information, to be able to see what is stored in the table to be able to update information in the table and so on. So now in databases, apart from deciding on the names of the columns, you need to indicate the data types. What kind of information will be stored in each column? Now, this is important because it can offer a measure of credibility and integrity to your information. So you need to think clearly about what kind of information is going to be stored in each of the column in a table. So for example, I might have the members table. The member ID might be for number. The first name would be letter or string. So okay, so you can have that kind of information. So in this column, you have numbers which are representing member ID. In this other column, you have first names, which is those are strings, as well as this one. In this one, you have dates, and again here you have a string. Okay, so SQL Server has a set of data types which you can choose from, and you need to be aware of their limits and their characteristics. So I want to quickly look at that just now. Okay, so the data types in SQL Server can be divided into a few broad categories. First of all, you can have the numbers. Then you have approximate numeric data. Then you have dates, and then you can have strings. These are the common types of data types that we'll be using in our lesson. And I'm recording. Okay. So the first set of data types are to do with whole numbers or integers. Integers are whole numbers, and they can be negative or positive. And SQL Server has a number of integer subtypes. The first one is just int, which is for the standard integer. And this is used for any number that is within this range, -2 to the power 31 to plus 2 to the power 31 minus 1. So you'll be talking of numbers that are in billions and trillions, okay? So if you are going to have numbers within this range stored in that column, then you can use the int data type. Secondly, you can have smaller numbers, which will be in the range of thousands, okay? You can use small int, and this will have numbers between minus 32,668 to plus 32,767. These can be both positive and negative numbers, whole numbers. Then there's tine int, tine integer. Tine integers, this is a special group or type where you only have positive numbers from 0 up to 255. So, for example, when you have a column where you want to indicate the number of books borrowed by a member in a library, definitely no member is going to borrow 32,000 books at once. So you can use tine int because you expect that the member will borrow books maybe 2, 3, 4, at most maybe 10 at once, okay? But then there are cases where you have to deal with very big whole numbers. For that, you use big int. And these are numbers which are between minus 2 to the power 63 and 2 to the power plus 2 to the power 63 minus 1. Again, this can be both positive and negative numbers. You also need to take note of the amount of storage space that is used to store these numbers. Different data types are going to take up different amounts of data on your computer storage. So, in order to make your database efficient, to make efficient use of the hard drive space, you should choose the most suitable data type. Of course, when you're planning for a database, you should be aware that businesses tend to grow, and so there are likely to be some changes in some of these columns. And so you don't want to be too economic whereby you have, with just a minor change, you start getting error messages. So you have to use your discretion to see what will be the most appropriate data type for each column. The other data types are decimal. These are for real numbers where you have number with decimal places. Again, there is decimal and numeric. These typically are identical, and I'll be using them interchangeably. I'll not make any distinction between decimal and numeric. Float, real, are approximate numbers. And these are numbers where the accuracy is going to vary and can introduce errors. So you only use these data types for columns where a level of accuracy is important, but where you want to deal with exact values, for example, money, you should not use float or real data types. If you are dealing with money, you also have the option of using money, which has also a subtype called small money. For smaller amounts of money with 2 decimal places, you can use, with 4 decimal places, you can use small money, okay? So you have to look at what type of information you're going to store in that given column and choose what is the best type of data type to use. Strings have, let me just switch to SQL. For strings, you have char for character and varchar. These are common use for strings. There is also text, and you use them where you want to store information that is not going to be used for calculations. So char, this one is fixed length. This one is variable length. What I mean is, for columns where you are going to have data of the same number of characters. For example, you have invoice code consisting of 10 characters. For that, you use the data type char because it's going to maximize on space. Varchar is variable character, and you use it where the data that is going to be stored in that column is not going to have any specific size. For example, a column for first name. First name of people will vary. Some people's first name will only consist of 2 letters, others will consist of 17 letters, and so on. So for such type of columns, you can use varchar. Then text is where you want to have a column where you are going to store long text. For example, you are building a website where members will be able to write blogs, articles maybe consisting of 10,000 letters or characters, and so on. So for such columns, you can use text because this one can accommodate much more text than a varchar and char. Typically, this has a maximum value of 255, and that's 255. Okay. Okay. So these are some of the data types that we'll be looking at. The date and time data types are date, time, then there'll be time, then there'll be date, sorry. And then there's also date, time, too. Okay. The difference between this one and this one is that this one will take up less space, storage space, than this one. So we'll be using where you need to have a column where there will be dates, say 1st January, the 10, 15.0, maybe 093. When you have that kind of information, you have to use date, time, or date time too. But where you need to just store the time, then you can use time. Or if you're just going to store the date, you use the date. So these are some of the data types that you are going to be using as we create tables, okay? So what we are saying is when you are creating tables, you need to assign the names of columns like that. And then for each one, you specify the size, the data type to be used for that column. So if I was to make a table for members, I would say member ID, I would searcher, and I'll put a maximum, a fixed size of 4 characters. First name, we can say virtual, and we can say up to maybe 25 characters. Last name, virtual, again up to 25 characters. This one, we are not interested in the exact time that someone was born, so date will be good enough for us. Again, for this one, address, we can have address, we can use virtual, and maybe we can say 200, okay? So those are some of the data types that we can use. Now, I'll come back to this subject later. So now I want to just go back to Management Studio and look at how you can query data from the database. SQL Server comes with a database, a sample database called AdventureWorks. It's not automatically available. So when you install SQL Server and then you install SQL Server Management Studio, you need to point the database to the database engine to where this database is stored. And you do that by right-clicking on the name in the Objects Explorer, you go to Database, right-click, then Attach. Then you'll be able to locate the database that you want to attach so that it will be recognized by the database engine. Okay. As it is, I've already attached AdventureWorks, so it's there. And I have a few more other databases that I've attached or created, as you can see from there. Each of these databases is going to have a number of objects or components that are associated with it. A database diagram is like an entity relationship diagram showing a logical representation of the relationship between the different data items in your database. And you can create it if you need to. I'll be showing you as we work on some of these examples. Apart from that, you also have tables. Tables, these are the basic components or objects that are used to store data. So data in a database, like we said, relational database, is stored in a table. And whenever you create a table in a given database, you're going to find a table in a folder called tables. There are other objects that make up a database, such as views. Views are like logical or virtual tables. where you can take information which is stored in different tables and bring it together so that when a user is viewing it, it will appear like it's in one table. Again, we are going to go into the details of views. Please, if you have questions, you can stop me and ask. Okay, so to start working with a database, you have to create a new query by going there and clicking on new query. Okay. So when you start a blank new query, this is where you can enter your code. For example, I want to create a new database. So I'll say create database. So I'm creating a new database and I want to give it that name. I'll say underscore. So when I enter a statement like that, SQL Server is not case sensitive. In other words, this statement can also be typed as and so on. All these are going to be treated as same commands. They're going to have the same effects, okay? Now, in SQL, it's advisable but not required to put a semicolon at the end of each statement. So you can put a semicolon there, can put a semicolon there. In SQL Server, this is not mandatory. It's not compulsory. But in other database systems like MySQL, it is a requirement. You get an error message if you leave out the semicolon. So you can just get used to that, okay? So I can go ahead and create this table, this database, sorry. So what I do is first I highlight the command that I want to run. Then I click on execute or press on F5 on the keyboard to execute the command that is highlighted. If I don't, if I just click on execute, all the commands which are in this new query window are going to be executed. And as you can see, I've used the same name of databases for each of these, and I'll get an error message. Okay, so I'll go ahead and create a new query, which I'll call unza underscore library. And as you can see, it doesn't appear anywhere there. Okay, so once I execute the command, okay, I get confirmation that the command has been completed. It will not appear automatically. I need to refresh. So I go to databases, right click, then refresh. Then I'll find it there. Okay, if I check, Again, our database database diagram, it will be empty. Tables, again, it will be empty. There will be no tables. Views, external resources, synonyms, programmability, service broker, storage, security, and so on. Okay, so that's how you can run a query in SQL. Okay, so I've created a new database and I'll quickly create now a table where I'm going to store information for the members. So I'll say create table. I'll be using capital letters for keywords just to make it easier for you and me to identify which one are keywords, which are used, which are recognized, or which have special meaning in SQL Server. So I'll create a new table, which I'm going to call members, open bracket. Again, I am indenting this, not because it's required. There were extra spaces just to make it easier to read the code when I'm typing. So according to what I have there, these are the details I have. So I'll go back. So the first one is member ID. And then that's the name of the column. I need now to assign this a data type. And for now, I'm going to just say numeric 4,0. And this is going to be, will not accept to be blank. So I'll say not now. And I'll set it as a primary key. Next, I'm going to have the first name. And this one is going to be virtual, maybe 25. Last name. Date of birth, date. And then address. Address, and I'll say virtual. Okay, now you have noticed I've put a semicolon at the bottom here. It's because from there up to there, this is actually one statement. I've just put it on different lines to make it more readable, okay? If I wanted, I could have put everything in one line like just there, okay? But to make it easier to read it, I've put each column on a separate line, okay? And then for the description or definition of each column, which is from there up to there, I'm putting a comma. So when there is a comma, it means that that's it for that column. This column is just the name and the data type. And then on the last column, because it's the last one, I did not put a comma there because it's the last column. So I just put that, then put the closing bracket. Now, if I was to execute this command, the table is going to be created inside a database called AdventureWorks. But I don't want. I want the new table to be inside this new database. So to do that, I use a command use, then the name of the database. Then I can go ahead and create now this database. Okay, so the table has been created. And if I go back to this, I can refresh and go to tables, and I'll find this table. If I want to open it and see what is in it, I'll just right click on it, then edit top 20 rows. Then it's going to be open. And as you can see, there is nothing that I've entered in this new table. It's blank. And I can type in the information. Member number 1 could be, that's the number. First name could be Betha Njogu. Date of birth could be maybe 15th 06 2000. So you have seen that because I'm getting that error message saying invalid details because of what I've entered in this one. This is because my system is using the American format for dates. So I'm supposed to say 06 and nothing not. Okay, 15 into close dollar. Okay, so I've entered the data for the first member in my table. Okay. And as you can see, I'm not using the command line to enter the data. If I have to view the information which is in this new table, I use a statement called select star from followed by the name of the table, which is members. So I'm able to see that the member ID is 1001. First name is Betha, last name is Njogu. Date of birth is 2006/30. Address is 14 Chintu Close in Dollar. Okay. So to view information from a database using commands, I use the select statement. The star here indicates that I want to see all the columns in the table. And if I add more members, for each member, I'm going to see information on all the columns. That's what the star means. Okay. Any questions? Any questions?
So I wanted to ask,
Yes.
what's the limit for a numeric data type?
What do you mean?